This week we're going to talk about inheritance. This is the next step in object-oriented programming. And normally I don't do a lot of slides, I just jump right in, but there's a confusing aspect to this if you've never done inheritance before. And so I want to kind of lay that out at the beginning. So inheritance basically lets you create a hierarchy of classes. So you have a parent class, kind of your main class, and then you can have subclasses or child classes that go underneath that. The child classes inherit all the functions and attributes of the parent class, and then they can also add their own or redefine them. The important thing is that you have to have what's called an is-a relationship between the child classes and the parent class. And that's always written in all caps like this, but it is actually the words is-a. So you should be able to say that the child class is a same thing as the parent class. And so it's a little bit easier to talk about that with examples. So you want to be able to say X is a Y if X inherits from Y. Some good examples of this, if we have a class for vehicle, we could have a class called car that inherits from vehicle because we can say a car is a vehicle. So they have that is a relationship. One is another. It's a specific subtype of a vehicle, but a car still is a vehicle, and so that's fine. If we have an animal class, we could say a dog is an animal, and so it's fine to have dog as a subclass of animal. You could also have humans as a subclass of animal, and you can actually have subclasses of subclasses. So we could say we have a class called golden retriever, and that's a subclass of dog, and that's fine because golden retriever is a dog. If you have a chain of inheritance like that, so if we have a golden retriever class that's a subclass of dog, dog is a subclass of animal, the inheritance works all the way down. So golden retrievers would have access to all of the functions and attributes for any animal. Looking to examples that we've done, we've been building games, so we could have a game class like we built last week, and then maybe I want to write a program to do tic-tac-toe. We could say that I have a class tic-tac-toe that's a subclass of game, and that's fine because tic-tac-toe is a game. Some bad examples, and it's actually really common to do this wrong as you're getting started. But the way that this goes wrong often is when you have a part of relationship instead of an is a relationship. So you try to take something that's part of something else and make it a subclass. That's incorrect. You don't want that to happen. So, for example, say you made classes for cities, states, and countries. So every country could get its own, could be an instance of the country class. Every state could be an instance of that. Any city you wanted would be an instance of the city class. You can't make these subclasses of one another. So you could not say that a city is a subclass of state because a city is not a state. It's part of a state, it's maybe in a state, but it's not a specific kind of state. And similarly, you couldn't say that states are countries. Here we're talking about like US states. The United States is a country. Maryland is in the United States, so it's in a country, but you can't say Maryland is a country. Any state is not a country. And so because they don't have that is a relationship, they have a part of relationship, you cannot use inheritance for that. And so this is an important thing to keep in mind as you're putting these structures together. That said, let's jump in and write some code. Okay, so what I have here is the game that we wrote last week. You can go download that code from Canvas because we're going to start with this. And what we put together here is a game where, if you don't remember, we could pick the number of players that we wanted, and then each of them would roll a die, and whoever had the highest number on their die was the winner. So we kind of had this really simple dice game just to get used to all of these features of classes. But this class game, though it's specific to the game that we have here, does have a bunch of generic characteristics of any game. So any game that we want to implement would probably have a list of players. We would want to keep track of who's the winner, and probably the number of players in the game. So all of those things are still there. If we're actually playing the game, we know that we want to be able to play the game. Now, what actually happens for that gameplay would be different for each game. So this dice game will have a different thing that goes on here than if, say, we were to implement tic-tac-toe. But there should be that PlayGame function. Roll die, you may or may not want that as part of the game. So if you're going to have games that all involve dice, you might make rolling dice part of the game class. That might be something that you want to put down into a subclass. So the fact is that we've got characteristics here in our game class that any game might have. And so if we want to implement different types of games, we could keep things like the player list, the winning player number, the number of players in this game class instead of having to replicate them in each of the games, and then make our dice game a subclass of game, make tic-tac-toe another subclass of game. And so if we're going to do that, if we're going to build on this code, what I'm going to do is leave everything that we have in here for now, and then we'll start separating out what remains in this more generic game class that should be applicable to any game we want to implement, and then what goes into a subclass. So reviewing what we have here in the init function, we say, okay, we have a list of players, we've got the winning player number, we have the number of players, and that comes from user input. That's basically going to work the same regardless of what game we're playing. And then we're creating one player in a loop each time, so we get a player for each number that was input, and then we start to play the game. So this is actually a pretty generic initialization function that gets our players, creates the necessary objects, and then starts the gameplay. The actual stuff that's in the PlayGame function is going to change. And so all of this is really specific to our dice game, and so we may want to move that out into a new subclass that we create. And for now, I'm just going to keep roll die as part of the game class because lots of games do require dice rolling. So what we want to do now is leave all that generic stuff in the game class. So if we decide to do, say, tic-tac-toe, we've got that available to us. But we're going to make a subclass for our particular dice game. And then just to remember, instances of that dice game would be a specific game that's being played by a specific set of people. So when you run it, it's the actual game that you're playing. The dice game as a class represents generically what does it look like to have one of those games, but you'd have to create a specific instance of it to play. So we're going to create a class called DiceGame, and then if we were to go ahead like normal, we would create the init function that would do something and whatever other functions we wanted. We know that we want this PlayGame function just like we have it here. And so we would I'm going to put that down in here for now. But it's not quite clear what we want to do with init because we basically want to do the same stuff that's up in the game class. And all of this that we copied down, how you play the game, that really doesn't belong in the game class because that's specific to this dice game. And so what we need to think about is, one, how do we create the relationship to say that dice game is a subclass of our more generic game? And then what do we do to have this PlayGame function that we know everything has to have, but it's explained differently depending on which class you're using? So first things first, how do we say that dice game is a subclass of game? This is really easy syntax. Just after dice game, you're going to put the parent class in parentheses. And so if we add in this part, which looks sort of like a function, but it's not, we say dice game parentheses game. That means dice game is a subclass of game. Okay. Now what do we do about this init function? Because we basically want to do the init function that's up here in game. This has all the stuff that we want. So how do we just duplicate that down here? If you ever ask that question, should we just duplicate it? The answer should pretty much always be no. You don't want to duplicate code. And so how do I say in the init function for dice game that we just want to go do what we have up in game? So there's a couple possible solutions you might consider. One would be just to leave off the init function and have it do the one that's in main game function. If we don't have one here, maybe it'll use the parent one. Unfortunately, that's not true. You have to have an init function in every class. And so we have to think of another solution. How do we tell this init function to go do the init function for the parent class. And so to do that, we're going to do it kind of like we called every other function. So we have the class name, which we've seen before, and then we just do init, which is the function name, and we pass it self because we know it has to have that. And that's it. That goes and executes everything that's up in the init function for game. And then we could add in other lines down here if we wanted to. One thing that we might want to do for that is to change the init function from game, where we basically get all of the players and then we immediately say, go play the game. We might want to take this out of the game class, because if I want to do some additional stuff in my particular game, I don't want it to do the init, start playing the game, and then have me do the extra steps down in my own init function. So I'm going to take that out of init for the parent class. So it just sets up the players. And then down here in the DiceGame, I could do other stuff if I wanted to. I don't really have to here. And then go ahead and say PlayGame. So I'm going to initialize the game as a whole, which will set up the players. If I had to do any other stuff, I could do it here. And then I'm going to call the PlayGame function. Now, what do we do about PlayGame? I know that everything that I have up here in the game class, this is supposed to be generic for game. None of this really should be here. So, because that's all specific to our DiceGame. So I'm going to delete that. I have it all copied down here in PlayGame in the DiceGame. And for now, I'll just put in here this little note just so we kind of know when that's getting executed. And now down here in PlayGame, if I wanted to say do whatever is in PlayGame up there, I could do the same thing like I did with init. Game.playGame and pass self. But all that's going to do is print something, so I'm not going to bother doing that. Instead, I'm just going to leave the code I copied down, which is the actual code that plays the game. This should all work basically the way it is right now. So what we've done in the game class is really simplified things. This is the whole game. So we have init, we have PlayGame that's not doing anything. We just kind of have it here because we know we want all of the subclasses to also have a PlayGame function, and we've left in roll die. Down in the DiceGame, this is a subclass of game. It has to have its own init function, and inside it we basically say just do the parent one. And then we also have a PlayGame function. This one is going to override the one that's in the parent class. And that has all the stuff that we had originally written to play the dice game. Nothing else has changed. Now we made a lot of changes, so I expect we've probably introduced a bug or two. But generally the code should work like this, so let's give it a try. Okay, so we're going to do python game2.py. It's working so far, which is good. So let's say we're going to have 2 players. Okay, and so it sort of worked. We've got the 2 players entered, and then nothing else happened, so we didn't actually get into the gameplay. So that's what we want to go debug and see what's happening here. Okay, so we're doing self.playGame in the init function, and the question is that happening? So the way that I like to debug is print something that just lets us know, all right, we've finished that step, and now we're going to go on to PlayGame, and in here I'm going to print and so what this is going to do is let us know when we've finished the initialization step, and then we'll know if self.playGame got called because we have this print statement here. So let's try that again. Okay, and so we're not getting to that point of the game playing, so we need to look more closely at that. We're doing player 1 and player 2. The game's not playing. So I've figured out what the error is here, and I hope some of you have caught it too, and that's because we didn't change anything else, right? All we did was change the game class to basically pull out the gameplay. We put that down in the dice game, but I didn't change anything lower down. And so what I've done here is I say, all right, let's go play a game. And the only thing you can do when you play a generic game is enter the number of players. We have not said that we're going to play this particular dice game. And so I need to change this to say, all right, make an instance of DiceGame, and now we should see all those debugging statements. So I didn't make this mistake on purpose. As I've said, I let you guys kind of see the natural programming process. But this really highlights why it's important to do these print statements as a method of debugging, because it allows you to see, all right, we know that this executed successfully. We see the steps happening in the init function for game, but we never get to the print, and there's no reason that we wouldn't get there. And so it suggests we're maybe not in this function at all. And that's how I was reminded that I forgot to change this code down here. So change that to DiceGame, and now this should work a little bit better. So we'll still have 2 players, A and B. Okay, and so now we can see my debugging statements were initialized and we're starting gameplay. It says A, it's your turn, hit enter to roll. B, it's your turn. Everything works fine. So we really didn't introduce any errors other than needing to update that one line. Okay, so I'm going to come in here and delete my debugging statement since I know that's working. Now, one other thing to note here, if we come back and take a look, is that we did initialized and then we did starting gameplay. Never did the PlayGame function in the parent class get called because we didn't see this get printed out. This is the game class's PlayGame function. And so that's just an important note for you to know that even though we have a PlayGame function in the parent class and in the child class, and the game that we made is both a dice game and a generic game, it's going to use the function that's defined in the sort of most restrictive class. So in this case, DiceGame has a PlayGame function, and so it's not going to bother doing the one in the parent class. But what if I were to change this? So let me just call this a different name right now. So we don't have a PlayGame function in the dice game. Well, what happens? We do init. That's going to do the game init. And then we have self.playgame, but there's no playgame because I changed the name here. What's going to happen? So if we do this again, it works fine. And what it does is say this is the game class's playgame function. So I've said, for this particular instance that I've created, play the game. Well, there's no playgame function defined in DiceGame anymore because I changed the name down here. Does that mean that self doesn't have a playgame function? That's not what it means. Self absolutely has one because it's defined in the parent class. And so anytime you have a subclass relationship like this, an instance of the subclass, in this case an instance of DiceGame, has access to all the functions in the parent class, all of the game functions. And so if we have PlayGame in the parent class and we don't define it down here in the subclass, that's fine. Anything in the subclass has access to this and we'll just use what's defined in the parent class. We actually already have done that in here because roll die is only defined in the parent class and we use that all over the place down here in the actual gameplay. We did self.roll die and that's fine. It just used roll die as it was defined in the generic game class. So if you have 2 functions with the same name, one in the parent class and one in the child class, an instance of the child class will use the one defined in the child class. If you don't have one defined in the child class, like here where I changed the name, it will look to the parent class for one. So that's just to kind of highlight that you do inherit everything from the parent class, but you can redefine it if you want. So I'm going to fix that back to where it should be so you have the right thing. But that's, again, just so you can kind of wrap your mind around having access to functions in both places. Now, we could make another subclass of game. So we could have a class called, I'll do TTT for tic-tac-toe, is a subclass of game. It has to have an init function, which I'm just going to copy from here, copy all of this. And for do other stuff, I may do something, and we won't write this now because we don't need to implement a whole other game, but I might do something like check we only have 2 players or fewer, because you can't have like 5-person tic-tac-toe. So I may throw an error if somebody said that it was more players than that. I may also just want to redefine this init function altogether to just say there's 2 players, so just tell me what your name is. And then we also want to have the PlayGame function. And that's going to have all of the stuff for playing tic-tac-toe. This is an assignment that I may give you at some point, but we could do something like printing the board. Something like that, which is going to be ugly, but will work. And then we just want to change our game type down here just to see that tic-tac-toe working. So I'll say 2 players, A and B, and it's a really ugly tic-tac-toe board, but you get the idea. So both of these are inheriting from game. They're using the game class's init function to get the number of players and get their names, and then doing their own thing for PlayGame. Okay, so the main things to keep in mind here, new syntax. If you are creating a class that is a subclass of something else, the parent class goes in parentheses. Remember, that has to be an is-a relationship. So tic-tac-toe is a game. Our DiceGame is a game. Player is not a game. Player is something in a game, but it's not a game itself. And so we don't make player a subclass of game. Anytime you have an instance of a subclass, it has access to all the methods of the parent class. All those functions, any attributes, all of those are accessible directly, just like we talked about here with self.rollDie. Even though that's defined in the parent class and we're in the subclass, it works fine. Because if you are a game, you know what roll dice is, or what roll die is, even if you're a particular kind of game. And you can have functions with the same name as the parent class. If you don't define those and you try to use them, it'll use what's in the parent class. If you do define them, they will override whatever is in the parent class.